Hi guys, this is Charles 2 and this is my Physics 2212 Lab 1 on charged sticky tapes. Today we will be observing the charged tapes interactions with surroundings due to their electric charges and fields. Some things to know beforehand: Newton's second law, net force is equal to change in momentum over change in time, and also equal to mass times acceleration. So if there's no acceleration, it will be equal to zero. The gravitational force is equal to mass times gravity, the gravitational constant, and then Coulomb's law, which is the electric force, is equal to kq1 q2 over r squared. Our assumptions that there are no air resistance, no humidity, the charge will be evenly distributed, and that we can assume that we'll be acting as if the tape is a point charge. Then our system will be the tapes, and then the surroundings will be everything else. So our experiment is we have two tapes, and then also a base tape, which will be stuck to an even and hard surface. One tape will be ripped off the base tape to create a charge tape. We'll be observing its reaction with other objects like pen, the other charge tape, etc. You'll repeat this step with other tape to create the second charge tape. Then you'll place the two charge tapes near each other until one of them floats, and measure the distance between two tapes. So the length of the first tape was 0.2 meters, the width was 0.02 meters, the mass is 0.0002 kg, the distance between two tapes is 0.022 meters. The force of gravity, the magnitude of the force of gravity and electric force is 0.00196 newtons. The electric charge of the tape after calculations is 1.02719 times 10 to the negative 8. We get this force of gravity from just mass times the mass we found here times the gravitational constant. And because the net force is equal to zero, that means that the force of gravity plus the electric force is equal to zero, and then the electric force, the magnitude will be equivalent. And then following that, you can get the electric charge of the tape by the net force. Well, the force of electricity is equal to kq squared over r squared. Then you will isolate for Q, and you can find the electric charge as 1.02719 times 10 to the negative 8. So you can see here, these are our constants. The Coulomb's constant, 9 times 10 to the 9. Gravitational constant, 9.81. The electron charge, 1.6 times 10 to the negative 19. The distance, 0.022. Tape length, 0.2 meters. Tape width, 0.02 meters. And then the mass. As you can see here, this is where we do the net force is equal to zero, and we can find the electric force. And then once we find the electric force, we plug into that equation where we isolate Q from kq squared over r squared to get the charge of the tape, which is 1.02719 times 10 to the negative 8. And then once you find that charge, you can then find the electron deficiency by dividing that charge by the electron charge of 1.6 times 10 to the negative 19. As you can see here, the green arrow is the force of gravity, and the orange arrow is the force of the electric force, and because they're equivalent, it's floating. Then we did our coding if we acted upon the tape as a line charge, and then we ended up getting that the charge of the tape ended up being 4.40576 times 10 to the negative 9. And we can assume that this model is more accurate because when it is a point charge, it occupies no volume and has like very little mass, while the line charge will have volume and mass. So we assume that the line charge will be more accurate for the data. And if the electrons were negatively charged and protons were positively charged, meaning signs were switched, we can assume that there will be no change in our data because they will still attract because opposites attract and likes repel. So the positive will still be electric to the negative stuff. Likewise. Yes, that is my lab. Bye bye.